Welcome to the project demonstration of automated dual axis sun tracking system for optimal solar energy capture. So here in this version generally for solar tracking purpose means when you want to place a solar panel towards the sun, when the sun moving from east to west, and in the winter season the sun will deviate towards the south, so that is a north deviation, and we need to detect the sun position exactly. So these two servo motors are used to get the sun position in east to west movement, and these two LDR sensors are used to get the sun position in the north deviation when in the winter seasons the sun moves towards the south direction. So these two LDR sensors are used to control this base servo motor. So we are using the two servo motors. One is for x-axis, another is a y-axis in the north deviation, and this one is a east to west servo motor based on the sun position. These two LDRs will trigger the Arduino Uno board, and from there the system will control the two servo motors positioning. And whenever these LDRs were covered due to any reasons, due to the environment conditions or any full dust was placed on these LDR sensors, then they won't provide the proper input to this Arduino Uno board, so that the system can't find the exact sun position due to the in cloudy or rainy season also. So there the system will taking care of input from this RTC module, that is DS1307. So here the main inputs are LDR sensor as well as DS1307 RTC module. So whenever the LDR is not performing properly according to the input we have loaded inside this, then it will take the input from the real-time clock and place this servo motors towards the sun based on the timing inputs. So LDRs are directly high efficient one, but whenever they are not working, it will take the secondary source of input from this real-time clock. So based on the time, the system will place the solar panel towards the sun direction. So here these are the main features. To achieve the features, as we discussed, main important components are 4 LDR sensors and solar panel, and 2 servo motors are the output module, and DS1307 is the input module. And here we are providing the 5 volts power supply to the system. From this board we are going to distributing the 5 volts power supply throughout the input output modules. So let us see the demonstration. Right, so here when we place the lighting on this, so we can see this X and Y axis are controlling based on this lighting position. So when it is perpendicular to the solar panel, then it stops moving, and when it is moving downwards, then it's keep on rotating the servo motors. Same for this X and Y axis also. So whenever while moving this, if there is no input from this LDR sensors, see, we can cover this with the hand, then the system will take the input from the LDR. As of now it is dark, and we are demonstrating that at 7:30 PM. Now the system will place this to the 0. Right, you can see that it's entering into the initial position. Again it is controlling that. So when the sunlight is available, it will control that based on the sunlight, and no sunlight, it will placing into the perpendicular initial 0 position. So based on the time input, if we demonstrate the project on the morning session, then it will be switching to the morning 11 o'clock. The estimated sun direction will be placed with the help of the servo motors. Right, okay. So in this manner, in the two way, we are going to get the position for the solar panel based on the real-time clock as well as LDR sensors.